In the last exercise, I gave you a lab where you actually went through the process of dissecting a packet capture where ARP cache poisoning was going on. And ARP cache poisoning was a very critical technique to understand for a lot of reasons, but specifically in this course, we used it to discuss how you might capture packets, but also how an attacker might redirect your traffic so that they may be able to take advantage of it. And that's really where this next demonstration comes in. And this is not going to be a lab, it's just going to be a demonstration, but I want to show you what an attacker can do when they're conducting an ARP cache poisoning attack against you. And I want to show you how that manifests via a technique called HTTP session hijacking. And what we're going to do here is actually show you where a user is browsing a website, and we're going to use a very specific one that's known to be vulnerable. And we're going to show what the attacker can do by looking at the traffic of that user browsing that website and then stealing one of their authentication cookies to actually access the website as though they are that user and gain unauthorized access to a specific web application. So it's a pretty neat technique. So I'm going to show that here. I'm going to show actually what it looks like, the actual browsing, show you the packets and how we extract the cookie and use actually a browser plugin to access this web application in a way that's undesirable. So let's go ahead and get into the demonstration. Now, the first thing I want to show you is the attacker view. And we're looking at the attacker screen, and there's honestly not a lot to see right now. We're looking at something called DVWA, which stands for Damn Vulnerable Web Application. And it's the web application I'm going to use for this example because I know it's vulnerable to this specific cookie stealing technique that we're going to use, the session hijacking technique. So we're looking at a username and password screen, and I'm looking at this from the perspective of the attacker. So I have access to this system and that I can see this authentication screen, but I don't actually have any legitimate credentials to it. I don't have a username, I don't have a password, but I want to access whatever is behind this login prompt. We'll consider it sensitive information. So how can I do that? Well, what I've done, and I've already configured this, is I've configured ARP cache poisoning to poison a known legitimate user of this website, and I'm intercepting the communication between that user and this particular web server. So we can say for this purpose, I'm actually already on the network that the web server and the legitimate user are on. I've managed to get a foothold into the network, but I don't yet have access to this specific web application. So that could be on their network. This could also be happening at a coffee shop. I could be on the same public Wi-Fi as that user, and maybe the web server is out on the internet somewhere, but in this case, they're both on the same subnet, so it probably makes a little bit more sense that we go with the scenario that I've already got a foothold onto that network since everything's in the same subnet range. Now, in this case, we see that the IP address of the web server is 10.2.2.104. The IP address of the client who we're spoofing, who we're ARP cache poisoning, is 10.2.2.103. So you want to capture the traffic between these two devices. So I've set up ARP cache poisoning to do that very thing. Now you see down here below, I have Wireshark open, and I am filtering. I'm capturing 10.2.2.103 and host 10.2.2.104. So I'm capturing everything that's going between those two hosts looking for data. This capture is actually already running. We can see that here, but I've not seen anything yet. So next, I want to pivot over to the victim view, so the victim user, and show them browsing this web page, and then we'll see what happens when we switch back to the attacker viewpoint. So we're looking at the DVWA login page now from the legitimate user or the victim viewpoint. And it just so happens this victim has a legitimate login to this application. And not only that, they're an admin, which is even better for our attacker who wants to steal the highest privilege connection credentials they can. So I can go ahead, and I'm going to go ahead and just browse to a few pages here. You can see this is DVWA, which has a lot of great vulnerabilities in it. Really great for practicing both attack and defense, looking at those packet captures you generate. So I'm going to do a little bit of browsing here, and what we'll do is we'll pivot back over to our attacker to see if he's managed to capture any packets that are going to be useful to him. Sure enough, we look back at our Wireshark screen here from the attacker viewpoint, and it looks like we definitely have packets, so that's pretty cool. We see the user browsing to the website, and it's in HTTP clear text, so we can actually view the request. As a matter of fact, here's a request, GET request for a page we viewed, GET DVWA/vulnerability/CSRF here in packet 21. So I'm going to go ahead and stop this capture, and let's go ahead and dig into this a little bit more. I'll make this Wireshark window bigger so we can see it. Now what I'm going to do here as the attacker is I'm going to browse and look at the HTTP data, and notice here I have a cookie with a PHP sysID value. So this is a cookie being handed to the client, and it's a cookie of an authenticated user. So the cookie is what, in this case, the browser uses to prove that it's authenticated. There's a database entry somewhere on the web server that says anyone with this cookie value is authenticated and is a legitimate user of the site. So let's see if we can actually take this cookie and use it to our advantage to gain access to the site as though we are the victim that we're trying to attack. To make this happen, I'm actually going to go down here to the cookie pair and just copy this value out. We'll just tell it to copy the value of this field, and we're going to rely on a browser plugin. And there are a lot of ways to do this. You can use a proxy of some sort, but I'm going to do it very simply with a browser plugin. And it's a browser plugin called Cookie Manager. Pretty straightforward. So I'm going to go ahead and do this. It looks like we maybe already have some entries in here. I'm going to go ahead and let's go ahead and refresh this page, see if we get another cookie back. And it looks like we do. So I'm going to go ahead in here and go to this PHP session ID value, go in here and paste my cookie value. Let's go ahead and get rid of that. And we should be good to go. So I'm going to go ahead and do that. We'll go back out here. We'll go back to the main login page. And what do you know? We now have access to the system because we're using the same cookie that the victim was using. Notice I didn't log in. I just went to the main web page. I skipped the login page, and now I have actual access as though I am that user, and I can access all of these great sensitive pages that are available here. And I'm now using the same cookie ID. So just to overview again what I did there, I may have gone a little bit quick for you, but what I did was, as an attacker, I set up an ARP spoofing, or excuse me, an ARP cache poisoning attack that allowed me to intercept communication between the web client, our victim, and the web server, which is this DVWA application. You didn't see me do that. I didn't show that on the screen. We've already seen that in a previous exercise. However, I did that. Then I started capturing packets as that victim user was browsing to the website, authenticating to it, and generating that cookie. Once I was able to see that cookie, I could use the browser plugin here, this Cookie Manager plugin. There are a lot of them that do this. This is just one I picked because I knew it worked. And I was able to go in here and edit my PHP session ID and put in the PHP session ID I had stolen from the victim user. By putting that in, from the web server standpoint, I was that user. I essentially assumed their privileges and their rights to the application, and that took effect immediately once I generated my first request with that session ID. Now, you may say to yourself, well, Chris, looking back at this traffic, it looks like it's clear text. Couldn't you just get the user's password if you captured their authentication sequence? And you could if it's actually transferred in clear text. That's another attack vector that would be possible here. But it doesn't necessarily have to be that attack vector. The beauty of ARP cache poisoning is if you're doing it with an application that supports this, such as Kane, it will actually allow you to man-in-the-middle encrypted applications too, because they're being decrypted in your particular context on your machine. You're providing some fake forged certificates to the client, so they still think it's encrypted, and it is on their end, but you're decrypting. You're a transparent proxy, so to speak, in the middle of that application. So even if that's not the case, you can perform a session stealing activity or technique, even if it's encrypted on the other end. So that's pretty useful information. There are obviously techniques that the server administrators can do to prevent these types of attacks from going on. But in this case, we use DVWA just because specifically it allowed us to demonstrate this technique. Now, the interesting thing about this technique is it's something that still works on a lot of very big and popular sites. So it's something you do have to be concerned about. It's not going to work everywhere, but it is something you're concerned about. And this is really a prime example of why we always tell people not to conduct sensitive activities from coffee shops and public Wi-Fi, hotels, things of that nature, because it's very hard to detect that ARP cache poisoning is going on unless you have a utility that will do that for you. And once that's happening, attackers have access to a lot of information they can use. So hopefully you see the benefit here of what we've done, this example we've done, and why it's important to understand how these traffic redirection techniques work. Simply by an attacker having access to your traffic, they're able to do some pretty interesting things that you probably don't want happening.